Hello everybody, and welcome to my channel. Today I will solve several FE problems, several mechanics problems. So let's start with the problem number one. So which of the following is true for an object moving in dynamic equilibrium? So A, the net force acting on the object is zero. So that's correct. If it is in equilibrium, so the net force is zero. The net force equals the mass times the velocity. This is not correct. The net force equals the mass times the acceleration, and the net force is equal to the friction force only. So D is not correct. The net force equals the mass times the acceleration. Actually, the acceleration should be zero. So the net force is zero. But let's say the correct answer is A. So the net force must be zero. A simply supported beam carries a uniformly distributed load over its entire span. At which location does the resultant force act? So if we have a simply supported beam like this with uniformly distributed load, if this is the beam, now always the resultant force acts at the geometric center of the load distribution. So if the load, the distribution is, if the load is uniformly distributed, so the resultant force acts at the centroid of the geometric center, which is midway here, L over 2. Now, if the load is, for example, rectangular like this, in the geometric centroid of the load is 1/3 here. This is the resultant, and this is L over 3. Okay, so this is another. Now if we have, for example, the load is like this. If the load is like this, so the resultant force acts here. This is our resultant force, and it is L over 3 from this side. So always the resultant force acts at the geometric center of the loading. So at 1/4 of the span from the left support at midpoint of the beam. So this is the correct answer for the uniformly distributed load. So the next question. In a statically determined truss, which analysis method is typically used to calculate the internal forces in the members? So in truss analysis, we usually use mainly two methods of sections and method of joints. So method of virtual work, method of joints, finite element analysis, energy methods. So the correct answer is B, method of joints. We apply the summation of forces equal to 0 in the x direction and the y direction. Now, the next question, when resolving forces in a free body diagram, why are forces often broken down into perpendicular components? Now, when we solve static or dynamic problems, we analyze forces into two main in two directions, into two perpendicular directions. So we select the coordinate system, either x and y, and they should be perpendicular. So to determine the magnitude of friction force, so why do we do that? So to simplify equilibrium equations by independently balancing forces in orthogonal directions. So this is the correct answer. Now, if you look at the other choices, to increase the number of unknown, this is not correct, that's not correct. To avoid the need for moment calculations, also this is not correct. So the correct answer is B. Next question. We remove these signs, okay. According to Newton's first law, an object remains at rest or moves with constant velocity unless acted upon by a net external force. This principle is also known as, this is the law of inertia. So this principle is known as law of inertia. A static object remains static unless it is acted upon by an external force, and also an object that is moving at a constant velocity remains so until it is acted upon by an external force. So this is now known as the law of inertia. So the correct answer is A. Now the next question, which statement best describes the moment of inertia? Other choices, it is a measure of an object's resistance to rotation and acceleration about a given axis. So this is actually the correct answer. But if you are sometimes not sure of the definition, so you can look at the other choices and you can sometimes drop them because they don't make sense. So B, it is equivalent to the total mass. So moment of inertia is not total mass. So you can drop this answer. It represents the linear acceleration. Again, moment of inertia is not acceleration. So it is equivalent to force acting on the object. Again, moment of inertia is not force. So you can drop B, C, and D just by sense. Then the correct answer is A. I mean, in case you are not really sure of the definition, you can also look. You can sometimes be able to drop some of the choices. The next question. So let me remove these. In rotational dynamics, the term angular velocity refers to. Now it's asked about velocity. So velocity is change in displacement over time, whether it is linear velocity or whether it is angular velocity. So the rate of change of angular displacement over time. So this is the correct answer. Just let's look for the other options just to see what they say and if they can be dropped. Now, the rate of change of linear displacement. So since the question says angular, so this is not correct. The change in rotational kinetic energy, again, this is not correct. Angular velocity is not kinetic energy. The torque, so this is also not torque. Velocity is not torque. So you can also eliminate B, C, and D if you are not sure of the definition. But always velocity is displacement over time, whether it is linear velocity or it is angular velocity. The next question, when analyzing motion in a rotating reference frame, which fictitious force acts outward away from the center of rotation? Now in circular motion, an object that moves in a circular motion, so the force that acts outward is known as the centrifugal force. We know that there is a centrifugal force that pushes the object outward. If an object moves in a rotational motion like this, so there is a centrifugal force that pushes the object outward. Now the centripetal force is downward towards the center. So the correct answer is B. Now the Coriolis force and Euler force, these are different things. So for an object moving in a circular motion, the centrifugal force acts outward and the centripetal force acts onward towards the center. So this one, because it says outward, so the correct answer is centrifugal force. Next question. Which property is defined as the ratio of normal stress to normal strain within the elastic limit of a material? Now, stress-strain relationship is governed by the known equation, stress-strain relationship within the elastic range. You know the stress-strain relationship is something like this. Now, this question repeats between different exams. It says it goes up like this, then goes like this. Okay, so this is sigma, this is stress. And this is strain, epsilon. So there's an elastic limit here, and there's then a yield limit here. So within the elastic limit, the relationship is governed by sigma equals E epsilon. This is the relationship. So the ratio between stress and strain is Young's modulus of elasticity, E, which is Young's modulus of elasticity. Sigma is stress and epsilon is strain. Now this question is repeated among the tests. So, and also other questions are repeated between the relationship between sigma and epsilon. So this curve is important. This curve and this relationship are important. So you should understand the elastic limit and also the yield limit and also the ultimate limit. So make sure that you understand these definitions. The next question. So Hooke's law for elastic material is expressed as, so this is we just talked about, this is the same question actually, it's very similar. So sigma equals this one, this is Hooke's law, this is known as Higgs law. Sigma equals E, which is modulus of elasticity multiplied by the strain. So sigma equals E epsilon. Sigma equals E epsilon. This is very well-known formula in mechanics of materials. Okay, for a rectangular subject to bending, the maximum bending stress at the extreme fibers is calculated by. Again, this is a repeated question. It repeats among the different exams, FE exams. So make sure that you understand this principle. So when a beam or an object is subject to a moment, so this moment causes a stress, and this stress changes if we have a rectangular cross-section, changes along or across the cross-section. If we have the cross-section, we have a rectangular cross-section. If this is the center line of the cross-section, if this is the center line, so the stress changes along over the, if this is the center line, so this is Y, for example, you can move upward and downward. So stress is expressed usually by A, sigma equals MC over I, where C is the distance from the center line upward or downward. Okay. Now, if this is H, if the depth of the cross section is H, so this is H over 2. So the maximum stress occurs at the outer edge of the cross section here, the outer face, and also at the outer face here. Now, at one face, the stress is compression, and at the other face, the stress is tension. So the upper face, the stress is compression, and the down face, the stress is tension. So this is how this is the relationship between stress and moment. This is again an important formula. Make sure that you understand it because it repeats among the tests. The next question. Which diagram is commonly used to graphically represent the state of stress at a point in a material? So which diagram, stress at a point in a material? Now there are different options. Now we know that the diagram that expresses the stress commonly used to graphically represent the state of stress at a point is Moore's circle. But also you can look at the other options and you can drop some of them if you are not sure of the answer. So free body diagram, does not have to do with the stress. Shear and moment diagrams, okay, shear and moment diagrams, they show the shear and moment along a beam or along an object. Stress strain curve, so also this is different. So the best choice is Moore's circle. Now, the next question, Poisson's ratio is defined as the negative ratio of. So this is, Poisson's ratio, this is a definition. So Poisson's ratio is the lateral strain divided by the longitudinal strain. Now, if an element is subject to a tensile force like this, T and T, for example, so there's going to be an elongation. That elongation is going to result in strain in the wrong direction, and there's also going to be strain in the transverse direction. So the ratio between the transverse direction and the longitudinal direction is known as Poisson's ratio, and there is a negative sign. So axial strain to lateral strain to axial strain. So it is lateral strain to axial strain. I don't see the sign here. It is the negative of the lateral strain, axial strain to lateral strain to axial strain, shear stress, not shear stress, normal stress to shear. So the correct answer is, or the most correct is the most possible is A. It is lateral strain to normal strain, but there is a negative sign, okay? Because the stress in the or the strain in the transverse direction is going to be negative. Okay, the cross sectional will be smaller. So to obtain a positive value for the Poisson's ratio, so it is defined as the negative of the lateral strain divided by the normal strain. So the next question. Okay, let me remove this. The modulus of resilience of a material is defined as, okay, this is also a definition, the total energy absorbed per unit volume up to fracture. So also this has to do also with the stress strain curve. So the total energy absorbed per unit volume up to fracture, the maximum elastic energy absorbed per unit volume, the initial slope, so it is not a slope. Now the slope of the stress strain diagram is the modulus of elasticity. Now the ratio of ultimate strength to unit strength, this is also different. It has to do with the safety factor. So the correct answer is B. It is the maximum. Is the maximum elastic energy or the maximum energy absorbed per unit volume up to elastic point in the stress strain diagram. The next question, which of the following best describes the behavior of a ductile material under load? So we have different options, or all it fractures suddenly without significant plastic deformation. This is not correct. Now, this is a brittle material. So if it is a material is brittle, it does not allow elastic deformation. If it is ductile or elastic, it allows plastic deformation. So it exhibits large plastic deformation before fracture. So the correct answer is B. It allows or exhibits large plastic deformation before fracture. So this is the correct answer. So next question. The maximum toughness is defined as. So this is another definition that relates between energy and the stress strain diagram. So maximum stress as a material can withstand. Toughness is not the stress. Okay, it is different from stress, so it is not the stress. Total energy per unit volume that a material can absorb before a fracture. So this will be a correct answer. Ratio of yield strength to ultimate strength. This is not correct. Initial elastic energy absorbed in the material. This is also not correct. So toughness is B. Total energy that can be absorbed by a material for fracture. So total energy per unit volume that can be absorbed by a material before fracture. So this is again a definition. The next question, for a circular shaft subject to torsion, the maximum shear stress tau maximum is calculated by which formula? So for torsion on a shaft, so shear stress is defined by actually A, which is tau equals tau maximum equals the torque multiplied by the radius divided by J, where T is tau is the maximum shear stress, T is the torque, the applied torque, R is the radius, and J is the polar moment of inertia. So the correct answer is A. So the next question. In a standard tensile test, the yield strength of a material is defined as, again, this is about the stress strain diagram. So it is important to understand the stress strain diagram and the key points there, the key stress, the key definitions, because there are always several questions in the FE exam about the stress strain diagram. So the yield strength is defined as the stress at which a material first begins to deform plastically. Maximum stress the material can withstand, no. Stress at which fracture occurs, no. The ratio of ultimate strength to elastic, again, this is not the yield. So the yield is the point in the stress strain diagram where the material starts to deform plastically. So the correct answer is A. So that's all for today's video. If you have any question about the problem solved in this video, please leave me a note. If you have a problem that you need help with, please also send me in the comment and I will address in the next videos. Thank you for following my channel and I look forward to seeing you in the next videos.